First of all, let's go back to the original function. And you can see that both original function as well as f prime have 1 plus tangent x. So here's a comment before we move on to part B. Well, maybe right now it's not is a good place since I wrote already B. We need to note that both f of x and f prime of x do not exist when or if 1 plus tangent x equals 0. So that kind of gives you the vertical asymptote. Okay. So when this happened, well, for 1 plus tangent x to equal 0, it forces you to have tangent x equals -1. Okay, and this happened when x equals what? X equals, well, pi over 4 is +1, right? So we're looking at the second and the fourth quadrant. Remember, the tangent is positive in the first and third quadrant. If you don't believe me, go back and look at your unit circle. The tangent is positive when the sine and cosine have the same sign, JT. Let the calculator go. Okay. No need for calculator here. So we don't want the tangent to equals -1, so we don't want the tangent to be pi over 4 in the third quadrant. Well, that will be 3 pi over 4. We don't want the tangent, the x to equal pi over 4 in the fourth quadrant. Well, that will be 7 pi over 4. But where else? We can now continue to the next cycle. Each cycle is 2 pi, or 8 pi over 4. So we are looking now at something like 11 pi over 4, right? We add 8 pi over 4, 2 pi, or 15 pi over 4, and so on. So we continue like that. So how are we going to write it in summary? We're going to say that x, actually this is x cannot equal, we don't want, so x cannot equal 3 pi over 4 plus 2 pi n, comma, and then 7 pi over 4 plus 2 pi n being an integer. Positive int. Actually, it can be negative integer as well. I should have first trigged that, but so we don't want x to equal these values. The reason I keep it at positive integer because if you think about it, 7 pi over 4 is the same as negative pi over 4. Okay? So in other words, we rotate forward that imaginary circle. Okay, now we're ready to look at the horizontal. So this will be the asymptote. Okay? This will be really vertical tangent that are vertical lines. So horizontal asymptote require that the derivative equals 0. Horizontal tangent, I keep saying asymptote. Tangent require f prime of x to equal 0. We want the slope of the tangent to equal 0. So f prime of x, if you recall from the top, is secant x times tangent x minus 1 over 1 plus tangent squared. We took care of the denominator, but here we want the numerator to equal 0. And this happens if either secant x equals 0 or the tangent x minus 1 equals 0. Okay. But by definition, secant x can never equal 0. Remember the range of the secant? It's either 1 to infinity or negative infinity to negative 1, right? So, so here's another note. Secant x can never equal 0. Okay? Secant x is either less than or equal negative 1, or secant x is greater than or equal positive 1, right? So what's left is we want tangent x minus 1 to equal 0. So and the tangent equals 1 when x equals pi over 4, or in the first quadrant, and also the tangent is positive in the third quadrant. In the third quadrant it will be 5 pi over 4. And then we can continue and add 8 pi over 4, so we have 9 pi over 4, or 5 plus 8 is 13, so 13 pi over 4, and so on. Okay? So the general solution x equals pi over 4. Since the difference here is pi n, actually I can write it as, instead of 2 pi n and 2 pi n, we can say plus n times pi. Okay? And you can see pi is 4 pi over 4, so you have pi over 4, 4 pi over plus 4 pi over 4 is 5, plus 4 pi over 4 is 9, plus 4 is 13, and so on. So this is the solution, and again, n is an integer, so we can write it as n. This is not an epsilon, this is a membership symbol, and we can write it like so, where z, shaded z, is the set of integer. The way you read it, you read it as belongs to. When you see this symbol. Z is set of integers. Remember, integers can be either positive or negative. Okay, another example. Actually, let me stop the recording here and move on to the next example.